Welcome back to Low Stress Math with Mrs. Bono. We are going to interpret some graphs right now. Okay, the first one starts with Jada makes a graph to show the weight of a jar when it contains different marbles. Weight of the jar with marbles, weight in grams, and the number of marbles. Now, 0, it already has, it's not starting at 0. And I was thinking, why is that? There's no marbles in the, wait a second, the y-intercept. So let's highlight this y, which is a weight. It doesn't say weight of the marbles, it says weight in grams. And it doesn't start at 0. So that means we were weighing something in grams that wasn't a marble. So there's no marbles, but something still weighs a little bit. So what does the y-intercept in this represent in this situation? It's the weight of the jar. It's the empty jar. No marbles. But once you start putting marbles in, then it has a weight. So when there's 10 marbles, it's 40 grams. That's the first, quote, good point, because this is not a good point. You don't know what it is. So if I follow this up, here's the next good point, and it's 30 marbles is 100 grams. Now, because it's a graph, what can I do? Think about it. Rise over run, you're right. And now you got to look at what these are worth. Each box here is 20, 20, 40, 60, 80. So starting here, 20, 40, 60. My rise is 60. And that has to go over, now looking down here, it's by tens. 10, 20, 10, 20. My run is 20. So then I get, well, let's see, if I divide 60 by 20, I get 3. 20 by 20 is 1. But what does that mean? Well, weight is the rise, so it's grams over number of marbles on the bottom. So what is this telling me? The slope is telling me grams for one marble. It's 3 grams for one marble. What is that? Oh, that's the weight of one marble. So slope is 3 over 1, and it's grams over marbles. And I did all my work up here. Is that okay? Sure. I'm actually just going to draw a little arrow so they know that that's where my work is. I mean, anybody grading this has half a brain. They're going to see that your work is there, but that's okay. It's me. I'm a little old. What information does this tell you about the situation? Well, it tells me each marble weighs 3 grams. I think I spelled weighs. There's no T in that word. Each marble weighs 3 grams. I should learn to spell one of these days. Just getting old, Bono, just getting old. Here we go. Which equation represents the line shown on the coordinate plane? Well, first things first, you have to find the y-intercept. Here's y, and here's it intersecting at b equals 0. Right there, 0. So now I just need the slope. I need a rise and a run. So if I rise 1 and run left, 1, 2, 3, 4. Rise 1, run left, 1, 2, 3, 4. Left is -4. So rise over run. M equals 1 over negative 4. So here we go. Y equals mx plus b. Y equals negative 1/4 x plus 0. But adding 0 doesn't really change it. So that is actually my whole equation, which is D. Glad they gave me room to work. I like it when I have room to work. Okay, a line is graphed on the coordinate plane. Well, la-da-da, here's my y. I'm highlighting it. I'm even going to highlight the one over here because, you know, why not? It's right there. And line y equals negative x plus 2 will also be graphed. Okay, let's do that. Let's graph that. Y equals negative 1x plus 2, and it's 1 over 1, right? So start at b equals, well, mx plus b. B is 2. So start at 2. Okay. M is negative 1 over 1. So I'm going to rise 1 and go left 1 because it's negative. So from here, rise 1, go left 1. Rise 1, go left 1. Left 1. And I could just follow that pattern because that's a nice, easy pattern. And wait a second. I don't really... What am I doing here? What am I doing here? Where's my ruler? I don't know, Bono. What did you do with your ruler? You had one. You're getting all weird and ditzy in your old age there, Bono. Here we go. Connect those points. Draw the line on here. This is y equals negative x plus 2. And then it says, oh, what is the solution? We didn't do solutions to systems. Sorry about that, guys, but it's right here. It's 4, negative 2. All it is where the lines cross. That's a solution. Yay, I just covered a whole chapter in one problem. We will just skip that one. Here we go. Which proportional relationship has the greatest rate of change? Rate of change is slope, m. So in this one, y equals 7x, m equals 7. The value of y increases by 12 for every increase of 4 in the x. So y over x is 7 over 4. That's the m there. For this one, well, this one's going to be 8 over 2. How did I know that? Because change in y over the change in x, 8 over 2, which is 4 over 1. So m equals 4. And this one, let's see, what's going up here? 6 over 1. Rise 6. Rise 6. Run 2 boxes is 1. I hate that. Run 1. 6 over 1. M equals 6. So which is the largest number there? Well, we could put them all in order. So 7 divided by 4 is like 1.75. So that's the smallest. 7 over 4, and that's B. And then the next smallest is C, which is just 4 over 1. And then D, which is 6 over 1. And A, which is 7 over 1. A wins. A has the greatest rate of change. Did not like the way that one was written. Okie dokie doodle. Last page for these problems. Yeah, you know, only 10 problems. Here we go. Linear function m and p are shown below. Okay. In comparing the rates of change, slopes, which statement is true about m and p? Well, first of all, let's find out what the rate of change is here. 1 to 11 is 10. 0 to 2 is 2. So change in y over change in x is 10 over 2, which which is just 5. And this one has an m of 7. So function p, their rate of change do differ by 2. That's true. Their rate of change differ by, that is not true. Function m has a greater rate of change. No. They have the same rate, that's not true. Their rate of change differs by 2 because 7 is 2 bigger. Which set of ordered pair does not, well, you have to look at the first one. So 1, 3, 5, 7, 9, they're all different, so that's good. 2, 3, 4, 5, 6, they're all different, that's good. 0, 5, 10, 15, 20, all different, good. 9, 6, 3, 6, 9. Oh, not good. The 6s repeat and the 9s repeat. This one, not a function. Well, that's not good at all then. All right, the set of ordered pairs below represents a relation that is a function. Well, that's nice. At what point, which point when added to the set would form a relation that's not a function? So we need to look for a -2, a 4, or a 10, because if it repeats, it's not a function. 0, no. -6, no. 4, there's a 4 here and a 4 here. This would make it not a function. How about this? No. So if we added this 4, 2, it would not be a function because then the domain would repeat. Okay, the set of ordered pairs below represents a linear function. Yay! What is one other pair of coordinates that could be the missing ordered pair x, y in this set? Oh, well, let's see if we can find a pattern. -2, 0, 2. This could go, they're going up by 2, so the x could be 4. And what about here? -3, -2, -1. That would be 0. Ha. So I just would look for a pattern. And the pattern is -2, 0, 2, 4. That's the domain. It's going up by 2, so my x is 4. And the range is -3, -2, -1, and 0. They are going up by 1. So x, and that's the y, equals 4, y equals 0. That was not so bad at all. Okay, I'll talk to you soon. Take care.